Hello and welcome to the video. We're going to look at graphs, and in particular we're going to look at the straight line graph given by this formula, which is y equals mx plus c. M is the gradient or the slope, c is where it cuts the y-axis. So that's the general equation, and we've got three examples: y equals x, y equals 2x minus 1, y equals minus x plus 2. And now we want to try and draw these on a graph, sketch them. You can use graph paper, or you can just draw them on a board or sketch it on your jotter. So I've sketched them here on the board and I've color coded them. So y equals x is the pink line, y equals 2x minus 1 is the green line, y equals minus x plus 2 is the blue line. And what you'll notice is the first two, the pink and the green one, they have a positive slope or gradient. Example 1, the slope is 1 because it's just 1 times x, it's mx, so m is 1. The slope for example 2 is 2, and the slope for example 3 is negative, it's minus 1 because it's minus x plus 2. So m here is minus 1. And that's why when you go from left to right, for a negative gradient, it goes down the way from left to right. And for a positive gradient, it goes the opposite direction. It goes up from left to right. So the pink one's there and the green one's here, but it's going up from left to right. Now obviously the green one is steeper than the pink one because that has a gradient of 2. The pink one only has a gradient of 1. So that's why that looks steeper. And what you'll also notice about these three graphs, this is just a pure fluke. I didn't pick these equations on purpose. I just chose them at random, but they all intersect at that point there, which I've circled with a black dot. And that is the point x equals 1, y equals 1. And that can be quickly verified. So y equals x, obviously, so 1, 1, that works for that one. Plug what x equals 1 into example 2, so that y equals 2 times 1 minus 1, which is 2 minus 1, which is 1. And then y equals minus 1 plus 2, which is 1. So that's quickly verified. But again, as I say, that was a pure fluke. But in terms of drawing the graphs, there's a very easy method I use. You can use different methods. But the one I use, first of all, I draw a little table like this. Now what we want to know is, we want to know what's called the y-intercept, and we also want to know something called the x-intercept, which isn't really talked about very much. So what happens is, to get the y-intercept, you have to let x equal 0 in each of these equations. So if you put x equals 0 there, what is y? Y is 0. So then that's the y-intercept. If you put x equals 0 here in example 2, you get y equals minus 1. So that's the y-intercept for the second line. And again in here, minus 0 plus 2, y is 2. So for example 3, the y-intercept is 2. And I've marked those on the graph. So the blue line, you can see the y-intercept is 2. Green line, the y-intercept is minus 1, and the pink line, obviously 0, because y equals x. And then we can do the same for the x-intercept, which is where each line cuts the x-axis. It's not as easy to find this because you have to make x the subject. So what you're doing now is you're letting y equal 0. So if you let y equal 0 in example 1, then x is equal to 0, so the x-intercept is 0. In example 2, if you let y equal 0, then 2x minus 1 is equal to 0, so 2x equals 1, so x equals a half. So that's our x-intercept. And finally, minus x plus 2 equals 0. So you just take the minus x to the left-hand side, so that means x is 2. And I've marked those on the graph. 0, half, 2. You can see those. So for each we've got an x-intercept and a y-intercept, and we only need 2 points, and then we join them together to form a straight line. Now let's just quickly look at the one for y equals x. So for y equals x, the intercept is 0 and 0 for both. So we can't really do much for that because the intercepts are the same. So we would need another point. So let's look at the green one. So for the green one, the x-intercept is a half, so it's a half 0. And the y-intercept is -1, so it's 0 minus 1 is the point, the coordinates. So that's down here, and the other one's up here. And then we draw a little line between them, and that's it. And then you extend the line this way to minus infinity, and this way to plus infinity. And then for the blue one, the x-intercept's 2, y-intercept's 2. You draw a line between them, and then extend it up left to minus infinity, and down to the right to plus infinity. And that's basically it. Once you have 2 points, you can just join them together, and then you can extend it as far after that as you want in each direction. So that's a simple enough way to draw the graphs. And points of intersection, which is this one here, that's pretty easy to find. You just let them equal each other. So y equals x, y equals 2x minus 1. So you just let the right hand side equal each other. So you set x equal to 2x minus 1 and solve for x. And that will give you your point of intersection for the pink and the green lines. And then you do the same for the other ones. Now, what I want to get on to, which is very important, is this parameter called m in the general equation. Now, m here represents the slope or the gradient of the line. And it's the rate of change of y over x. So it's the increase in y over the increase in x. So if we draw a few values here in a table, and we take the example 2, which is y equals 2x minus 1. So here m is obviously 2. But why is it 2? Well, the only reason I can tell you it's 2 is because I know the general formula, which is y equals mx plus c, but I haven't really done any working out. I'm just going by the formula. But if we draw some values in a table, so x equals 0, 1, 2, 3, 8, and then y is minus 1, 1, 3, 5, 15, respectively. So plug in x equals 0, you get y equals minus 1. Plug in x equals 1, you get y equals 1. Plug in x equals 2, you get y equals 3, and so on. Now, if you look at the first few values, x is incrementing by 1. It's going up in 1 each time, 0, 1, 2, 3. And y is going up in 2s. Minus 1 plus 2 is 1, 1 plus 2 is 3, 3 plus 2 is 5. So the difference between the previous value and the next value is 2 on the y side, and for x it's 1. And then I've thrown in another example, 8, just to demonstrate it more clearly. So y equals 2 times 8 minus 1, so that'll give you y equal to 15. Now the reason I've done that is just to seal the deal. So 3 to 8 is an increase of 5. So there's a difference of 5 there. 5 to 15 is an increase of 10. So there's a difference of 10. So the change in y is 15 minus 5, which is 10. And the change in x is 8 minus 3, which is 5. And then the change in y over the change in x is 10 over 5, which is 2. And it's always going to be 2. Now, I'm not just saying that because I know the formula and I've read that m equals 2. Yeah, that's all true. It's all interlinked. But let's go and prove it. So I'm going to quickly prove this now. So you just have a wee look at this, and I'm going to be back in a wee second. We're going to prove this. Y is m always equal to 2? For example, 2. So we're pretending that we didn't even know the formula. Imagine we didn't even know the formula and we had to prove it. Okay, so what we're doing is we're changing y, and we're changing x, and then we're seeing how much y changes, and then we're taking the ratio of y over x. So it's the change in y over the change in x. Okay, so if we started with any value of y, let's call it yb, use the subscript b. So that's any value of y. You just let b equal any number. So it could be any one of these. Okay, so that will be equal to 2xb minus 1. Because if this is yb, then this will be our xb. So the subscripts have to match, right? So this could be, say, xa, but you wouldn't use xa and yb in the same formula, okay? Because this input does not give this output. To get 15, we need to have an input of 8. So this is xb and this is yb. This is xa, this is ya, xc, yc, etc. Okay? So you have to be very careful when you write out the general formula. So that's the general formula. So yb equals 2xb minus 1. That's the equation of the straight line. So for any particular value of x, so say xb, our y value will be yb equals 2xb minus 1. But we're not done yet, because we need to compare the change in y over the change in x. But we've only got one value here, so we need a second value. So let's do another one. Let's do ya. So again, we just follow the same rule. So this is a different value of y, and this is a different value of x from the one up here. So, well, they could be the same in theory, but we'll assume they're different. So xa is some other value of x that we've chosen. For example, 2. xb could be 8. But in general, we don't know. It could be any, right? Okay. So now we want to know the change in x over the change... Sorry, we want to know the change in y over the change in x. So the change in y is simply yb minus ya. How much has ya changed to get to yb? So 5 to 15. It's 10, isn't it? It's 15 minus 5, it's 10. Right? But in general, we just write it like this, okay? Okay, and then, so we subtract this from this, okay? And what does that equal? Well, that's equal to 2xb minus 1 minus 2xa minus 1, right? So that's equal to 2xb minus 2xa, because the minus 1 and the minus 1's cancel, because minus 1 minus minus 1 is just 0. And then we can simplify that, or we can just tidy it up and write it as 2 times xb, take a 2 outside, and we get 2 times xb minus xa. Right, great. So now we're nearly home and dry. So m equals the change in y over the change in x. So it's yb minus ya over xb minus xa. Okay, so yb minus ya equals 2 times xb minus xa. So we divide this by xb minus xa. Or I can just write it up here. I'll just write it in full. These cancel. 2. Okay. So how easy was that? And in general, obviously, if you use the general straight line equation, let's go and do that. That'll be fun, yeah? And that'll just really seal it for you. Let's go and use the general y equals mx plus c straight line formula. And if that doesn't convince you, then nothing ever will. But I've hopefully convinced you there without even using the formula. Okay, so the general formula for a straight line is y equals mx plus c. So let's follow what we did earlier, and we will replace y with yb, and so that'll be equal to mxb plus c, because y only depends on x. Y is our output, x is our input. So for a given input x, you'll get an output y corresponding to the input. Okay, and then similarly, ya equals m times xa plus c. Now we don't even know what m and c are at this point. Doesn't matter, right? This could be any numbers. So let's go and do what we did earlier. So we take yb minus ya, because that's the change in y. Okay? And what does that equal? Well, that's just equal to m xb minus xa. I'll do it a little bit quicker this time. The c's cancel, obviously. So it's this minus this. If you've ever done simultaneous equations, if you've got a number on the top and the bottom, then they just cancel out. And then because we have an m top and bottom, the m will come out, and then you're just subtracting that from that, or that from that. So that's what we've got now. And then, so quite simply, you divide across by xb minus xa, and that equals m. So there you go. How easy was that? And that doesn't even depend on c. So m is always equal to the change in y over the change in x for any given x value that you choose. Then you find your y value, and you do that again and again and again, and you compare them, take their difference, take the ratio, and it's always going to be m. Okay guys, so in the next video we're going to be looking at quadratics, parabolas. So that's the next sort of degree up. So these are linear equations of degree 1. So the power of x is 1. Okay, but we're going to be looking at squares in the next video. So have like x squared plus x plus 1 or something like that. So it'll have an x squared term. So I hope you enjoyed the video. Thanks for watching. Please like, share and subscribe.